This lesson is on difference of two perfect squares, also known as dots. If two terms in a binomial, so binomial is two terms, are perfect squares separated by subtraction, then you can factor them. To factor the difference of two perfect squares, remember the identity. So it's kind of like a formula. An identity means any numbers you put in here, it is true. So a squared minus b squared equals a plus b quantity multiplied by a minus b. So it doesn't matter what numbers we put in for a and b, this would be true. So this is kind of like our formula for difference of two perfect squares. To the left, we have a chart. So this is x, and this is x squared. So these are your perfect squares. So we have a couple examples. So the perfect square of x squared is x and x. The perfect square of 16 is 4 squared, so 4 and 4. You do not have to show this second line. If you just want to go to the answer to factor, have at it. So again, 4x squared is 2x quantity squared. So the perfect square of 4x squared is 2x and 2x. Perfect square of 25 is 5 squared, so 5 and 5. And the last example is probably the most difficult because it's not just squareds. We have to the 6th power and to the 8th power. So a difference of two perfect squares, any even power is a perfect square. Okay. So 9x to the 6th, the perfect square is 3x to the 3rd, because x to the 3rd times x to the 3rd, right? X to the 3rd times x to the 3rd, we add the exponents, so we get x to the 6th. Okay. So y to the 8th is y to the 4th. Y to the 4th times y to the 4th. Again, we add the exponents. All right. So our formula is 3x to the 3rd minus y to the 4th and 3x to the 3rd plus y to the 4th. Okay. So it doesn't matter if you put the minus first and the plus second or the plus first and the minus second. No, it does not. All right. So challenge yourself. Try to do the next 3 examples. And continue the video to check your answers when you are done trying. Okay, so the first example wasn't terrible, pretty straightforward, but the second and the third example, we were tricky and super tricky. In the first one, or the second example, the first of the tricky ones, you needed to take out the GCF first. You should have noticed that 18 and 32 were not in your chart above. So, but a hint would have been x squared and y squared. So you should always look for the GCF first. Then, once we took out that 2, they were perfect squares and it was a difference. So I used my difference of two perfect squares identity above. And I got 3x minus 4y and 3x plus 4y, but I need to remember to bring down that 2. Remember, when you factor, your answer has to be equivalent to what you started with. So if I multiplied this constant in these two binomials, it better equal what I started with. That's how you can check yourself. The last one wasn't too bad. So it was an even power, and it was a difference. And 1 is in my chart, it's a perfect square. So I used my formula above, and I got x squared minus 1 times x squared plus 1. But then x squared minus 1 is still a difference of two perfect squares, so I had to factor that more. So I used my formula above, or my identity above, and got x minus 1 and x plus 1. The biggest mistake you guys make is that you try to factor this x squared plus 1. But it's not a difference, so I cannot factor it. It is prime, not factorable. All right. If you have any questions, don't hesitate to ask. Good luck.